Today I'm going to be talking about I'm going to teach you how to solve quadratic functions. First, we have to start by learning factoring. This is really 2 lessons in one video. In a regular classroom, I would be doing this over a few days, but this is for my summer school class. And if I ever teach Algebra 1, I'll probably use these videos in Algebra 1. Anyway, I digress. Probably a multi-day adventure. So let's multiply these 2 binomials. So, FOIL, first terms together. Outer terms together. Inner terms together. Less terms together. Okay, so notice that when I simplify, first term is the product of those. The middle term is the sum of 4 and 3. And the last term is the product or the multiplication of 4 and 3. So now I'm going to be giving you this. Oh, that's not what I wanted to do. Now I'm going to be giving you this. And we need to get back to that. So if you remember, this is the sum, and that one's going to be the product. Okay, so to factor this, so there's a lot going on here. What I want you to focus on is I want you to focus on this. Okay, here. I'm always going to be looking for 2 numbers that multiply to be the middle number. Add to be the middle number and multiply to be the last number. Okay, so in this example here, we were looking for 2 things that multiply to be 8. So what you want to first start looking at is looking at the factors of 8. And then we'll figure out what the sum is, because I want to get the sum to be 6. So factors of 8, 8 and 1, 4 times 2, 8 and 1 sum is 9, that's not 6. 4 and 2 sum is 6. So that's why they chose those 2 numbers there. So factoring this x squared plus 7x plus 12. An x times an x. Both this is positive and this is positive. If those are both positive, you put a plus sign in the middle. So I now need to look for the factors of 12, and then we're going to see what the sum of those numbers are. So factors of 12. 1 times 12. That sum is 13. That's not 7. That's not what I need. 2 times 6. That sum is 8. Nope, I need 7. 3 times 4. That sum is 7, so one of them is plus 3. One of them is plus 4. Oh, wait, was that the example we just did? Hey, that was just the example we did. I didn't even plan it that way. I don't know if I like that or don't like it. Okay, now factor each one of these. So, we always start both of these are positive, so both of those are plus. So we want the factors of 24, and then we got to figure out their sum. So 1 and 24. That sum is 25. I need it to be 11. 2 and 12. That sum is 14. 3 and 8. Ooh, 8 plus 3. Hey, that's 11. So I have plus 8 plus 3. This example I'm going to rewrite. Okay, so I need factors of 9, and then I need to look at their sum, because I need the sum to be 10. This middle number is what I need the sum to be. Okay, factors of 9. 1 times 9. What's their sum? 10. Oh, sweet. First one. First shot. Okay, now, these are going to be a little bit more complicated. Because what I have here is I have two numbers that are going to multiply to be a positive number, but add to be a negative number. So that means both have to be negative. So when I'm looking at my factors here, I just need to understand that both are negative. Factors of 27. And then I need to look for their sum. Okay, 1 times 27. That's 28, or technically -1, -27, -28. -2 doesn't go in. -3 times by -9. Well, that's -12. So I have x minus 3, x minus 9. Okay, so here, next we have w. So same thing. Two things that multiply to be a positive, but add to be a negative, they both have to be negative. Factors of 28. -1 times by -28. Remember, I need their sum to be a -11. That's a -29. -2 times by -14. -16. 3 doesn't go in, 4 goes in. And there I get a -11. So I have w minus 4, w minus 7. Okay, now this one's a little bit more complicated. Because positive and negative. So my two numbers have to be opposite signs. So one of them's going to be positive, one of them's going to be negative. Okay, because a negative times a positive gets me this negative number, but a negative plus a positive is going to get me a positive number, depending on which one is larger. So I now need to look at my product. I'm sorry, not the product. The factors. And then we're going to look at their difference. So factors of 18. 1 times 18. 18 minus 1 is 17. I need that difference to be a 3. So 2 times 9. Their difference is 7. I need it to be 3. 3 times 6. Their difference is 3. So what you need to remember is that because this 3, because the 3 is positive, the 6 has to go to the positive and the 3 has to go to the negative. Because positive 6 plus a negative 3 is a positive 3. Okay, now this one, again, I need a negative here, so I need one of them has to be positive, one of them has to be negative. So we look at our factors of 20. So our factors of 20, 1 times 20. I look at their difference. Their difference is 19. 2 times 10. Difference is 18. Oh, wait, no, is 8. I was trying to go too fast. 3 doesn't go in, 4 goes in, 4 times 5. Their difference is going to be 1. But I need it to be a negative 1. So what I need is I need to put the 5 with the negative sign and the 4 with the plus sign, because negative 5 plus 4 is going to get me that negative 1. And again, remember, you can go through and you can remultiply these together. You can FOIL those out to make sure you get the right answer. That's how you would check your work on this. Okay, steps to solving equations by factoring. Make sure you have these in your notes. Get one side of the equation to equal 0. Factor the polynomial. Set each factor equal to 0. And then solve each factor for the variable. Again, take a minute to make sure those are in your notes. Okay, get one side to be 0. Okay, I'm good. Luckily, my equation's already set equal to 0. So now I have to factor this. Now both of these are positive, so I don't have to worry about negatives. So factors of 24, they're going to add to be 11. 1 times 24, that's rarely one of them. I think we already did this one. 3 times 8, well, that is going to be 11. So one of my factors is plus 3. One of them is plus 8. Okay, so let me go back to our checkoff list. We had one side to be 0. We factored our polynomial. Now set each factor equal to 0. And that's called the zero product property. Meaning that, remember that anything times 0 is 0. So that means that n plus 3 could equal 0, or n plus 8 could equal 0. Now I subtract 3. I subtract 8. And there are my two answers. Okay, I have to get one side to be 0. And now I factor. Now since I have my product is a negative number and my sum is a positive number, one has to be negative, one has to be positive. So then I start looking at the factors of 15. And because I'm negative, I need the difference. So I look at 1 times 15. Well, their difference is 14. 2 doesn't go in. 3 times 5. Oh, their difference is 2. 5 has to be the positive one because my 2 is positive. Now I set each factor equal to 0. And I solve each equation. Okay, solving this equation by factoring. I have to get one side to equal 0. Now this one's a little different because it's not the factoring pattern we've been doing. And I think I put this one in here and I think we actually cover it in a later section, but I want to preface it now. This is factor by GCF. So my greatest common factor is k in both terms. I'm left with a k minus a 7 equals 0. Set each one of my factors. So one of them is equal to 0. If I add 7 over, I get k equal to 7. So that is my video on solving quadratic equations.